Hello, this is Stephen Barr. Welcome to AWS Made Easy, your weekly live stream where we interview AWS guests from the community and other AWS users. We review and rate AWS articles, and we do our best to answer your questions. Now, Rahul is out today, but we had a really cool interview from Compute Optimizer. We're really glad to have had that opportunity. Now, before we jump into the interview, I wanted to share a few really good announcements. So I'll put these on stream. First one, we had just published our blog on the cost and usage report, the CUR. Now, I've put the link to this in the comments. I'll have it in the show notes. This is a really good blog post, the cost and usage report. It's where all your really useful data comes from. This is where you get to see exactly how your spend is allocated to the hour per service. We had a really fun intro to this post based on Star Trek: The Wrath of Khan. So I'll let you have a look at this. The link is in the description. So check out this foundation series. We call it Foundational Skills. It's the cost and usage report, CloudWatch, and Systems Manager comprise our foundation series, because that's where you can get all of the data and all of the control to really get started on your cost optimization journey. So go check that out. Seeing people join the stream, thank you so much for being here. Please leave a comment, say hello. We're really glad you're here, and please ask any questions that you have. All right, next announcement, we have the Seattle AWS Users Group coming up. That is a great meeting to go to. That's hosted at the AWS Skills Center on Terry Avenue. And it happens to be that I'm speaking on September 26th. So if you are interested, as many watchers of this show are interested in automating AWS cost savings, please come to my talk in person, say hello, ask questions. That should be a really fun evening. And there's lots of other good talks by the AWS Seattle Users Group. I help run it. We meet at the Skills Center. We have a really good time. We get pizza and have great discussions about all things AWS, different users of AWS. Last month, we learned about Hoodie, the distributed database engine. So we always have good, engaging content. So hopefully you can stop by if you are in the Seattle area. The link is in the comments. All right. Also coming up soon, I hope you had a chance to see. Let's close that. We have an end user computing episode coming up on Friday. Now, this is with Sarah Pepper and Andrew Wood. This is going to be a really fun episode. Now, due to scheduling, it's not our normal Friday. It's not our normal Tuesday. This is going to happen Friday. So we're looking forward to that one. This is happening Friday afternoon, Friday 9 a.m. And they are both based in the UK. So it's Friday evening for them. So we're really grateful that they have made the time. We're going to be talking about end user computing. Also, we have a GPU right sizing mini episode. Give me one moment to put that on the screen. All right, let's put this on the screen here. There we go. We've got, as part of Compute Optimizer, there was recently announced a GPU instance right sizing recommendations. So Rick is going to join us for a special on Thursday morning. So we're going to discuss the GPU instance right sizing. So please be sure to join in for that one as well. And the link, of course, follow CloudFix page. Check the links that's here in the description for you. All right. Any other announcements? Oh, at the AWS Skills Center, let's put this on the screen. Give me one more moment here. There is a Cloud Exploration Day coming up at the AWS Skills Center. There we go. Cloud Exploration Day. Make sure to watch the Cloud Exploration Day. If you're in the Seattle area, this is Wednesday, September 20th, 10 a.m. to 3 p.m. This is talking about job roles in the cloud. If you know somebody who wants to get into the cloud, bring them to this event. This is going to be really exciting. And of course, the AWS Skills Center in Seattle is a great resource. If you want to learn more about it, check out our interview with Maria Petrova. She's the Seattle AWS Skills Center lead. That was about 10 episodes ago. So go have a look to that. We'll put the link in the show notes as well. All right, on to our main event. Here is our interview with Rick Ochs. Let's put that on screen.
Hi, everyone. Welcome to AWS Made Easy Livestream. Today we have with us Rick Ochs from AWS. Rick leads product management across all the compute optimization tools. Rick, tell us a little bit more about yourself and your role at AWS.
Yeah, thanks, Rahul. So I'm a senior manager of product management at AWS, and my team works on Compute Optimizer, reservations, savings plans, the recommendations for those services, as well as the Cost Explorer right-sizing products. So it's a family of products that help customers save money on their cloud bill, as well as improve performance.
So if anyone wants to see dollar bills in their accounts, they should be talking to you, correct?
You know what? I would say that so many of our TAMs and architects, right, we all help customers optimize. I mean, I spend the majority of my day trying to build the right products to help everybody optimize their cloud bill. So I love having those conversations too. But ideally, all of your AWS counterparts can help you save money.
Absolutely. And that's kind of, those conversations was kind of how we all met up, right? We were at the EBC in Seattle a few months ago, and we were there talking with you about Compute Optimizer, both in the context of CloudFix as well as the larger group that we represent and all the accounts that we manage ourselves. And the conversation was absolutely fascinating. And we decided to have you on the show because I think the larger, broader audience could also benefit from all those insights that you had during that session. So thank you so much for coming on the show and being with us today.
Yeah, my pleasure. We also had some very cool conversations at the FinOps X conference as well.
That is true.
That was a fantastic event to go capture some product feedback, customer feedback, and just sort of get the temperature on how the industry at large is thinking about right sizing. I still think maybe we're a little early in the journey overall in the optimization industry to really get a lot of companies to take right sizing more seriously, but it's a fun challenge, right? And the opportunity is huge.
I couldn't agree more. So before we dive right in to all the nitty-gritty details of Compute Optimizer and all the related services, why don't you tell us a little bit about your history at AWS? How did you come into AWS and this particular team?
Absolutely. So I've been at AWS for about 1.5 years now. I was hired to help lead the optimization product organization. Previous to that, I was the lead product manager at Turbonomic. And when I was at Turbonomic, I was there for 4 years. I had owned and worked on all of the right sizing capabilities there, the automation capabilities, support for right sizing across multiple different cloud types and things like that. And that included RISP, migration planning, forecasting, and my personal favorite, right sizing. And then previous to that, I was at Microsoft for 13 years, where the last few years, I owned the right sizing tooling and optimization program inside Microsoft IT. So I've been doing right sizing and optimization for like 9, maybe 10 years now. So I've been having a lot of these same conversations for a long time, but it's funny, they haven't really changed a whole lot. So, I mean, some things have changed. We have new tech, new tools, but the concepts behind right sizing have remained the same, which is fascinating.
It's really interesting, this idea of optimization. For background, I was in a operations management program a while ago, and we did a lot of numerical optimization, convex optimization, and I got to hear a talk from someone at Amazon Logistics, and they were doing combinatorial optimization for warehouses. And so that's literally certain shapes of boxes need to fit on the shelves. And they said that over time, they improved their bin packing algorithm so that for a given square feet of warehouse, they could fit, I think it was 6 times more stuff on the same shelves. And that's kind of what we're thinking about with, I mean, that's a really powerful visual, But right sizing EC2 instances is a similar idea, right? How do you take your workloads and get it to fit on the shelf, or in this case, the what's offered by EC2? How do you get it to fit just right and pack it in so that you're not wasting so much space, but you're still being able to store what you need to?
Yeah.
Yeah,
So
that's not a bad visual. Or
yeah.
one of my favorites is just, I don't know, for anybody in the audience that has children or young children, like getting them to turn the lights off when they leave the room, right? Like, or another funny one that I like to use in a lot of customer conversations is, when somebody first starts at a new job and the hiring manager says, okay, or IT says, okay, we need you to pick your laptop. Please indicate on this form if you need a 32 gig laptop or a 16 gig laptop. Like, what are you going to pick? Like, what's the incentive for ever picking the 16 gig laptop if the 32 gig is available, right? So we just have this human nature element that gets into optimization where by default, engineers typically will pick the most resource unbounded option, right? And so anytime you have like a UI or a script where you have to pick an instance size, you're just generally going to tend to pick the bigger one because it feels more comfortable to have more performance and capacity, right? It sounds better. He doesn't want a really fast
That's saying better to
instance.
have it and not need it than need it and not have it, right? And that, I guess, that feeling of permanence to our choices kind of invades our thinking about instances which really aren't that permanent, but we still have that idea of, what if I need this?
Well, they used to be permanent when everybody was working on-prem and we were all IT practitioners on-prem, and I used to order hardware for all of my solutions, and I would intentionally over order the hardware because I didn't want to have to get 2 years into a 5-year hardware lifespan and have to reorder the hardware.
Correct.
And not only that, but the extra cost of doubling the amount of memory was relatively cheap in the grand scheme of things. It's like, another $600 per server to double the amount of memory. So why not? Especially if you're going to have the instance for 5 years or the server for 5 years, a little bit of extra memory is kind of like an insurance policy. I mean, you might not need it, but you have it. And that sort of led to very low average CPU utilization, which was okay. That's okay when you own the hardware. It's not a big deal. But it was very permanent. It was this permanent experience where you're kind of locked in for 5 years. You don't really ever change. You don't touch the infrastructure. You don't change it. But of course, with these two, you should be changing it. You should be looking at it all the time. But do people? No, it's easy. You're busy. You're working on the next feature, the next improvement, the next project in your backlog, and you don't always think about, hey, should I go revisit that instance size I picked 3 years ago? Can we do better than the M5 that we provisioned? Like, the answer is yes, by the way.
100%. So let me start with this, Rick. I don't think the large portion of our audience really understands how big this inefficiency gap really is in their utilization. Are there any stats that you could share that kind of shed some light as to why this is important, why people should pay attention to this? Anything that you could share with us?
Yeah. So Compute Optimizer has vended over 6 billion recommendations since the creation of the product. It's interesting. The amount of recommendations people look at is astronomical. It's really exciting, the amount of attention we get. As far as when I work with customers and understand their environment and help them kind of think about and wrap their head around right sizing and the opportunity, it's sort of all over the place depending on the maturity of the company I'm talking to and if they're ready to take right sizing seriously or not. But it's very common where I see average CPU utilization in the low single digit percentages, right? And so I'll meet with Fortune 500 companies all the time, and average CPU is 6%, 7%, right? And that's common. And I've even had one company that I had a discussion with. They were struggling and they were working really hard at it, and they had hit 10%, and they felt like they were really failing. And I had to encourage them and saying, like, 10% is one of the best I've ever seen as far as really increasing your usage of your CPUs across the board. And they were relieved to hear that, and also horrified, Because if 10% is doing really good, what's going on here, right? Like, what's the problem? And what's interesting is like average utilization goes down when you go to faster CPUs, which is a good thing. So it's not always like a great KPI to track, but it's interesting information. And it is a correlation. There's a correlation between spend, waste, and something like CPU utilization. You can think of CPUs as kind of this currency almost, where you're trading dollars for resource, and that resource, one of the biggest cost drivers of the cost of each of these instances is the core. It's the CPU. Correct. So you can kind of think of cores as like a currency or a resource. And so as we select what kind of cores we want to use, how fast are they, how expensive are they, and things like that, we can sort of think about how are we spending these cores as a resource. And so something like a 10% average utilization, again, it's actually pretty good. And that's because there's still a lot of behaviors we have to go chase out. There's non-prod, there's dev, there's test, there's UAT, integration, test, backup, right? And so there's all of these extra environments that sort of are legacy IT thinking we don't really necessarily need to have in a cloud world where we have resiliency. We have a lot more native capability to run multiple environments and then turn them back off. Or only run 2 environments or 3 environments at a time instead of 7 or 8. Yeah. So I would say, I mean, from a metrics perspective, companies that do really well on right sizing, they start to hit double digits, and it materially has an impact on their cost. And it's not always about saving dollars. It's actually not about saving dollars. I would say it's more about making sure the spend you do have is lined up with the business value you're getting out of your resources, right? Yeah. So it's not really about just lowering the bill. In fact, I would even say, like, from a metrics perspective, the vast majority of customers that do really good on right sizing, the bill doesn't crater. What happens is the bill is, from a percentage perspective, more slanted towards things like serverless, ECS, EKS, or new technologies that can help them innovate. Yep. And so you see, like, really their bill is a reflection of their strategy, their attitude of how they think about cloud.
And so as really they implement the compute optimizer recommendations, the savings get reinvested into more value adding parts of their infrastructure. Like you said, machine learning, maybe serverless, other things that they can do. It's hardly ever, okay, great, we're going to compute less and then pocket the difference because that's the end of our ambitions on the cloud.
Yeah, I mean, 100%. We moved to cloud for like the elasticity and the agility and the new tech stack, right? These are the main business value drivers of moving to cloud, right? And using cloud. And so we want to go get these values. And if we're not right sizing, are we getting those values? That's the question I always try to ask, is like, if you just migrate, lift and shift everything and leave it static, are you getting that elasticity benefit you wanted? Right? Or are you just operating your cloud environment like an on-prem fixed infrastructure?
Yeah, I think I see a lot of enterprises continue to do that, where, on an average, I've seen that the utilization is only about 2% across large IT enterprise shops, especially the ones that did a lift and shift and kind of left it there and decided that that's going to be all and end all of their entire cloud migration process. And I think that's where they miss achieving the value proposition of the cloud. They misunderstand the value proposition of the cloud, because unless you're innovating, unless you're constantly evolving and use the cloud for all the agility and elasticity and growth, then you're really not leveraging the cloud for what it is really good at. So with that, I'm going to follow up with another question, which is something that I ask everyone from AWS, because this is probably one of the most asked questions to me when I talk about AWS. Why is AWS building these tools? What is in it for AWS to build out these compute optimization tools and help customers get more efficient? Because you would think that it would reduce customer spend on EC2 or whatever specific service. Why does AWS invest in teams, product solutions, TAMs, and all the documentation and the best practices and developer advocacy at the same time to get customers to be efficient?
I love this question, Rahul. I think it might be my absolute favorite question, because I asked this question when I interviewed, and sort of I grilled my interviewers about, is is the appetite for optimization really there? Like I want to join, but I want to be so totally dedicated to helping customers and really getting elasticity out of their cloud. And every answer was different, first off, and in a good way, because everybody had thought about this and had a nuanced personal vision for how they help customers on a daily basis. And every answer tied into the leadership principles at AWS. The first and most important leadership principle being customer obsession. So I got a lot of different answers, but all of them sort of thematically had the same passion behind it, which is, we believe that as we hold the reins to AWS, the reason behind AWS's creation was to provide that elasticity and cloud value. And we want to help customers achieve that. We believe a happy customer is a long-term customer. We believe that it does impact long-term revenue in a positive way because customers believe we're on their side. We help them. We support them. We want them to be very successful in their own business and in their own usage of IT resources. I love that. That's why I joined, just to be transparent, like to hear those sorts of responses from every single person I interviewed with. It meant that there was room in this organization for me and my thinking, and having been working on this for a lot of years, that, right, like we have a lot of maturity to do in the cloud optimization space. And the better we do, the more useful cloud becomes for the planet, and the more resource efficient we get on not just individual cores, but on power and cooling and the resources that are a little bit more limited on this planet. So the impact goes up pretty substantially when we use these resources more responsibly. And that's the future. We all need to do a better job being efficient with our resources and what we have, because there's a limited amount. Another example is like the GPU situation. It's hard to get a bunch of GPU capacity right now, right? This is a really common conversation that I've been part of the last few months. Right. Optimization is an important way to extract the maximum amount of value out of the resources you do have.
Yep.
And so I love that question. I relayed most of the answers I heard when I asked that question. I have my own personal sort of thoughts on that too, but it is why I'm here.
Well, I loved how you mentioned at the end of the day, all of these resources are a proxy for these fundamental resources like energy, right? Essentially EC2 is like the amount of compute you use is a proxy for how much power you're consuming, and so being able to do the same job with less power, that's a really powerful thing.
Yeah, absolutely.
No pun intended.
So let's talk a little bit about the tool set that is now out there for customers to leverage. So you've got the Compute Optimizer, and then you have Cost Explorer, you've got Kudos dashboards, you've got so many different tools in this space. So tell us a little bit more about the specific tools that you've been working on, and how should customers start looking at them?
Yeah, so I break down optimization into sort of four major buckets, which I think we talked about in our EBC, but
Yep.
Essentially like the four major ways to save money in the cloud safely without hurting performance is buying discounts, whether that's RIs and savings plans, right? Make sure you're fully utilizing the option to prepay for your resources that have consistent usage to get that discount. That's the first step because it doesn't require any engineering engagement, right? You can go and implement a savings plan approach and strategy and save, right off the top, a certain percentage of your bill that is meaningful and valuable. Then the next phase of optimization is generally cleanup. So that would be like deleting unattached EBS volumes, IP addresses. That gets a little bit more important now with the pricing changes to IPv4 addresses. Any sort of resource or object in your accounts that is no longer serving a purpose. Then you have suspension, which there are AWS provided solutions for suspension. And that is just turning the lights off when you leave the room, turn off your instances if they're not in use. You no longer need to achieve a 5 nines in your dev environment, right? This idea that you don't need constant uptime for a lot of these resources. They're a little bit more flexible, and we can treat them as such and receive a lot more value for them if we only keep them on when they're needed.
Yep.
And then lastly, right sizing. And I put right sizing last because the engineering effort is higher for right sizing. It's more complex. There's architectural impacts sometimes, not all the time, but sometimes if your right sizing includes Graviton, if your right sizing includes moving from Intel to AMD, sometimes a lot of companies want to do benchmark to make sure that that's a move that's not going to have performance implications, which the latest AMD instances, right, they're extremely fast, and it's a good move from a performance perspective. So for the fourth one, right sizing, we have Compute Optimizer. AWS Compute Optimizer is a first-party product we have in the console. It is a free product. You can go enable it on your accounts today, and within a day or so, you'll receive recommendations based on the historical utilization of your instances. So it'll look at CPU, memory, disk, network over 14 days by default, and then look at all of the available instance types and say, okay, this is the right instance type for this instance. And here's the price difference between your current instance and that recommended instance. And it does a few different things. It can help you modernize by getting on the latest instance family. It can help you migrate to something like Graviton if that's compatible and an interest to you, which has another additional amount of extra performance and savings. Or also like AMD or other CPU provider types. So you can kind of get this whole modernization thing done at the same time of right sizing. And it's great. It's a great combo because when you're moving to a faster CPU that's newer, say it's 5 years newer, 6 years newer, it also understands the performance difference between these cores. So instead of going from an 8-core to an 8-core, it'll go from an 8-core to a 4-core because those 4 cores are twice as fast as your older cores. So you can downsize the number of cores while modernizing at the same time. And it provides this cool experience where your app is faster. It is on a faster CPU. The request completes faster. And it might look slower because you have less cores, but it's actually faster because each individual core either operates at a higher frequency or has a higher efficiency per clock. It's called IPC, instructions per clock. It will be more efficient and faster, even though it has less cores. So you not only save cost, but you increase performance at the same time.
Got it. So the common question that a lot of customers ask us is, what guardrails does Compute Optimizer have to ensure that when you take up a recommendation from Compute Optimizer, you're not making any trade-offs on performance? So how do you address that?
Yeah, we have so many guardrails. This is an area that we work diligently on. We test ourselves constantly. We test ourselves to literally millions of recommendations going through validation to make sure we're not providing recommendations that are harmful. So some of the guardrails, so one of the most obvious guardrails is on utilization. We put all of the utilization data through an ML algorithm that detects and simulates what this utilization will do on the new instance size. And then we add a buffer on top. So there's a default buffer of something right around 27-ish% that gets added on top of all of the recommended sizes to make sure if you ever do have in the future an increase in utilization that you weren't expecting, that there's an extra 27% capacity on CPU, memory, disk, network, all of those resource types. So if there's unplanned, unexpected spikes in utilization, you still have that extra capacity to handle it. So what we're doing is essentially we are still oversizing a little bit, just to be transparent. We're oversizing a little bit, but not a lot. We're oversizing maybe 1 or 2 cores, or 20 something percent of that instance.
Right. I mean, when you're talking about single digit, utilization right now, the room
is pretty huge. Yeah. I mean, the opportunity is you can right size and save a ton of money without ever getting remotely close to performance issues.
So for context for our audience, so when you use Compute Optimizer for EC2, it's an API call, and you get back a set of recommendations for instance type and sizes that are categorized by risk level from very low, medium, and high. So you're saying even at the high risk level, there's still a healthy buffer. So high in that case is not high as in a high risk change is high relative to medium or low, but it's not high in terms of you might see performance degradation. It's still a very healthy buffer within.
No, yeah. So our definition for high is actually that you're making an architecture change. And so it's a little riskier because you're going to Graviton or something like that. And so we call it high because we don't know if your app is compatible.
Got it. Okay.
Right. So that's when you'll see high. It's not real. I mean, it might be that utilization will be a little higher, and that's true. That might trigger a high, but most of the time it's really just related to an architectural
Okay.
compatibility.
So then what
concern.
about medium? So medium versus low or very low?
So we consider lows for, when utilization is in the very low single percent, and it's very obvious recommendation that is just free money. And then the mediums are a little bit more like, hey, we see some utilization. There's a little bit higher risk when we move between instance families because the CPU and performance thresholds are a little different. We do track and manage the performance differences between instance families, so we know how the performance is going to change, but it does increase risk just very slightly because we're going to a different processor. It was maybe made in a different factory. It has a different clock speed, or it was made on a different generation of architecture from Intel or AMD. So there's a little bit higher risk there, but I wouldn't really call it high risk or even remotely close to it because we're doing all of that math for you. That's one of the guardrails that we have is to measure the performance difference between each of these families. So actually, that's another one of the guardrails. And then I have another guardrail too I can share, which is we do not size any resource type we don't have metrics for. And so this one is a big guardrail because if you add data, the product gets significantly higher impact for you. So let's talk about memory data as a guardrail.
Yeah.
If you have CloudWatch installed, or if you have one of the third-party APM products installed that Compute Optimizer supports, Instana, Datadog, Dynatrace, New Relic. So if you have one of these products and it's configured in Compute Optimizer and memory data is flowing into Compute Optimizer will downsize your memory. If we do not have memory data, Compute Optimizer will not recommend a downsize on memory. So what it'll do is it'll look for other instances that have the same amount of memory or more, and it'll optimize CPU, network, and disk, but leave memory alone. So there's no risk for you taking that recommendation. If you might have an application that's memory intensive and we don't see the memory data, it'll be protected. You can still take that recommendation and save money. But when you do add memory metrics, the number of instances that Compute Optimizer evaluates as a potential to migrate to is way higher. Because when we don't have memory, you're limited to only instances that are the same memory size or larger. And so just cross a couple hundred instances off the list of potential candidates to move to. So when we add memory metrics, we see an increase in savings multiple times over. So if you are trying to do a bunch of right sizing, the numbers look kind of small. If you add memory, boom, that number triples or more. And your optimization and right sizing initiative will just, it's like attaching solid rocket boosters to your program. It's just the amount of impact.
Oh, I love that visualization. That's really exciting.
Yeah. So Rick, you just said, I think you mentioned this, but I want to call it out explicitly. We were talking about a CPU and memory metrics, and you also mentioned that you take care of network and disk IO metrics as well to decide what the right sizing is. Can you talk a little bit more about that? Because I don't think everyone really understands that when you downsize, some of these other metrics could also change because the resources that are available to these instances is different. So if you can just talk a little bit about that to explain why you need all four to optimize and why that's safe, that'd be great.
Yeah. So you're right. We skip over that part of the conversation so often in right sizing, but various different instance sizes and families have different capacity and threshold for network and disk. The larger sizes, of course, generally have higher network and disk. And network performance is actually a function of how many network devices you have attached. The amount of network performance you get increases for each additional network device. And what happens is you have a limit at the network level per device, and then you also have a limit at the instance level. So you can kind of optimize in multiple dimensions here. Now, Compute Optimizer is looking at the instance level capacity for network and is saying, okay, if we downsize, the amount of network traffic, both in and out, because there's limits on both, the new size must be able to handle that amount of traffic without getting past, it's like roughly 50%, right? Because you never really want network traffic too much past 50%. You start getting packet collision and packet loss, and it's like this big disaster. it's one of the areas where getting to 100% CPU isn't really a big deal. Getting to 100% network is a huge deal. You shouldn't do it. So it's a little bit more of a sensitive area when you're right sizing. And so when we provide right sizing recommendations, usually down, we're looking at the network capacity of all of the instances available and saying, hey, can your current network utilization fit on the new instance size plus that 30%-ish buffer on top, right? So we're adding an additional layer of buffer on top of it to make sure that you're not going to have network issues at the new instance size. And it's interesting because we've got like a decade worth of different instance types to choose from. Right. And the network capacity can be vastly different depending on the instance type you choose. And price, there's a correlation between price and capacity, right? And so we can optimize that and save quite a bit of money. The same thing goes for storage as well, right? Certain instance families have certain amount of storage capacity. There's a storage capacity limit at the volume level and also at the instance level. We also provide recommendations for individual volumes as well. So we can optimize the volume and then optimize the instance that is attached to all those volumes. So you can optimize both layers of your infrastructure. And again, the amount of savings is pretty substantial when you're optimizing both layers.
Got it. So of all the services that Compute Optimizer looks like, so I think you guys started with EC2 as your primary service that you look to optimize, but that catalog has now grown to a number of different services or sub-services or related services. So tell us a little bit about that growth and all the different, other services that are covered under Compute Optimizer today.
Okay, so we have EC2, which is the primary use case, right? Most customers have a lot of EC2 usage, and that's where we talk. We have expanded into a lot of other services that customers have asked for and that we believe are great candidates to apply optimization thinking to. So we recently launched ECS on Fargate. Containers are such a great platform of choice for new design and architecture. It sort of breaks down your infrastructure into smaller bite sizes. Your containers are usually much smaller on average than instance size. So that makes them a little bit easier to manage, maintain, and move around. But just because they're in smaller sizes doesn't mean they're sized correctly. So you still have the same problem. You can still right size all your containers. And so supporting ECS on Fargate was a really cool advancement we made. We launched that end of last year.
Yeah.
We also support Fargate recommendations. We support autoscaling group recommendations, which are essentially EC2 instances in an autoscaling group. There's some limitations on that. The complexity of trying to size an autoscaling group is just incredible. It takes just a huge amount of brain power to figure out how to do that correctly. So right now it's limited to when all of the instances are the same size and you do not have autoscaling turned on.
Got it.
And we can constantly talk to, and also EBS, we size volumes, and we constantly talk to customers, and the number of services they want us to support is a list as long as my arm. So everybody wants to save money on everything. So I love hearing that feedback, and I have, we listen closely to that feedback and work diligently to try to increase the services we support and optimize.
That's a really, really neat context about EBS. And I like what you were saying earlier about you're not just fitting the CPU core or the memory utilization, but it's a lot of different things. It's network bandwidth and then the memory and the speed. It's a reminder of, buying a vehicle, right? When you first get into vehicles, you think about, okay, horsepower, that's the only thing. But then no, you actually think about trunk space and turning ability, because you don't want a dragster that can do one thing really well but can't turn or can't move, right? You need to have a balanced set of features where you often end up with a minivan, right? You really need to balance all your different constraints and make sure it can do everything that's needed of that instance.
Yeah. Or in some cases, you do want the drags. Like there are some apps that are like purely focused on a single dimension, right? I think a good example is the GPU instances, right? Like you're using those GPU instances for very, very specific workload, and you need them to do one thing really well. And so we account for that too, right?
Yeah, that's a really good point.
We can find instances. Yeah, we can find instances that have just an absolute huge amount of capacity in one dimension and recommend those as well.
One thing I wanted to ask about was the kind of the data sources and the value of the data. So we talked about when you brought in the memory data from CloudWatch, you get all this extra data. What's the value of the enhanced infrastructure metrics and increasing that horizon from 14 days to the 90 days?
Yeah, so just to add some background, enhanced infrastructure metrics is a feature in Compute Optimizer you can turn on. When you turn that feature on, the product, which by default uses 14 days of look back data to make its decisions and recommendations. When you turn on enhanced metrics, it goes to 93 days. And so now it's using 93 days of historical CPU, memory, disk network, all of the utilization data for every recommendation it makes. I typically hear this get raised as sort of a constraint customers have, and they're like, 14 days isn't enough data. Like, we want more data. We want our recommendations to account for our monthly behaviors, whether that's patching cycles, like we want our patching and maintenance behavior in the recommendation so that way it's more consistent. Or we have a quarterly cycle. Say you have an application that does like quarter close, right? And you want that utilization data to be considered in the right sizing recommendation. So enhanced infrastructure metrics is a paid feature, although the cost is very marginal, that you can turn on, and the recommendations go back 93 days, and they change a little bit because they have so much more data. But this can really help if you're running a program to help right size a lot of instances, and you're talking to different engineering teams and app owners, and they kind of are concerned about the 14-day data look back, you can go turn on 93 days. What's really cool is if that helps convince engineers that these recommendations are safe and accurate and trustworthy, even if that helps you take one more recommendation, right? The economic impact is absolutely worth it. The ROI is just is very nice. So this to me is an opportunity to sort of get rid of one of the reasons why people say, "Oh, I can't right size." Because I have that conversation a lot too. I'm sure you two both do as well. It's like, I go into these conversations all the time where, okay, we have a central FinOps team or optimization team, and they're trying to push these individual app teams to go right size. And I think it's interesting because the number one issue in the FinOps report is, the hardest problem to solve is getting engineers to take action. So it kind of turns into a problem of trust. So the enhanced infrastructure metrics feature is there to help sort of bolster the trust that, hey, these recommendations are, use an overwhelming amount of data.
Yeah. I would say that I think it's a combination of trust, which is one. And in general, when I speak to a lot of AWS customers, I feel like the trust is there because AWS usually doesn't release a tool or release a recommendation unless it's been thoroughly tested and you know exactly how it's working, and it's been, kind of tested on millions of instances or customers or whatever before it's actually put out as a GA product. So I think the trust factor is there. What I find more often is the inertia of changing something that is working, the unknown of what if something goes wrong, like why should I change if it's not a priority top down from the organization, or if the organization doesn't necessarily have a FinOps culture. So most FinOps teams basically struggle with changing that behavior. It's just human behavior change that they implement. And one of the tips that I actually spoke about in a webinar that I was doing yesterday was the idea of FinOps teams using chargeback as a mechanism to incentivize the right behavior. So, for example, if you want everyone to move to Graviton to be most efficient or move to AMD to be most efficient, then just use your chargeback mechanism. Have your Graviton instances be subsidized by the extra tax. So maybe you say, okay, if you're just going to be on the most expensive one, and if there's any Compute Optimizer recommendation that you haven't taken, then that instance is just going to cost you 2x more than what it is costing right now. And that way, there may be teams who have a genuine reason for not making the move, but it disincentivizes the default behavior of doing nothing. And it incentivizes actually making the change, making progress where it is possible and feasible to do that.
I see the same thing. When you can drive cost accountability into engineering, the cultural impact is very large.
Yeah.
That's hard to do though, because
It is.
I mean, we're talking about teams that were sort of incentivized for decades to not touch something if it's not broken,
Correct.
and that had no cost muscle whatsoever, right? And the entire cloud journey, as we go into sort of self-service creation of resource and building, we just provided a console to a bunch of engineers and was said, go build things. So what did they do? They went and built a bunch of stuff, which is great because we want them to. We want them to go
Correct.
in to create and stuff. But then you have this side effect where they have no experience whatsoever managing a budget. So it's like, who is the last person you would ask to go manage your finance budget, your IT budget? It'd probably be the developer. But
100%.
who did you give the keys to? The developer, right? So this accountability component, I've seen it work really well where organizations do monthly GM level optimization check-ins where they look at their bill together and they look at the recommendations together side by side.
Yeah.
And correlate the amount of recommendation savings potential versus the total spend. Yeah. Right. And that helps to like drive this conversation of accountability, and it helps the lieutenants or, the folks within the organization that report to a GM or a leader kind of start to understand that they actually have a bigger potential for impact in the organization than they maybe realize.
Yeah.
That they're controlling a pretty significant portion of their business from a cost perspective. So the opportunity is maybe something they didn't realize. And so it's a little bit of an education component that turns into culture of accountability. But those tools, the chargeback, the showback, the increased visibility, whether that's building a custom dashboard. We have a lot of customers that pull all of their recommendations via API, put them in a new dashboard, or they use potentially third-party products that pull the recommendations for them and show them.
Like CloudFix.
Like CloudFix, hey.
Yeah, they fix things automatically.
Yeah. So this visibility component is a really, really critical part of how to turn this into a cultural transformation.
Yeah, I think trying to build that culture from scratch is incredibly hard, and you have to use these other mechanisms to kind of seed your culture with a practice first, and that practice over a period of time just becomes culture.
It's interesting that you highlighted that tension too, right? Between if you tell the engineers, go build stuff, here's a bunch of different things that you can use. And then later you go around and then say, okay, let's optimize this for what you've built that you found to work. And that's one really good approach. But then the other approach could be cost conscious from the very beginning. But then do you ever worry that maybe they will take less risk because they're thinking about it too much? Like how do you kind of think about that trade-off of go make a mess, then we'll clean it up later, or be cost conscious from the very beginning?
It's all over the place. I've met some companies that are so risk averse, right, that they don't let anybody build anything unless it's an approved architect design that has had 6 months of sanding on it. And then other teams are just like, go build whatever, and they didn't know the sort of outcome that would have, and they're like, oops, right? Like, look at our build now. And so there's all sorts of maturity levels. If you build something from the ground up in a cost-conscious way, of course, it's going to be easier to optimize or keep optimized long-term because, the architecture and the components you used and the services you used are generally going to be a little bit more efficient in their nature. Trying to run a stateless service on top of EC2 is sort of difficult when you have something like serverless out there. You could just use that to start with, right? But then you think about when you're talking to companies, 95% of their tech stack is legacy. They don't have budget to go rewrite every single app every time they look at it. It's just not reasonable because their backlogs are generally adding new features and capability to drive their company and their business forward. Taking a 2-year pause to re-architect everything is just not realistic. And so this cleanup after the fact versus do it right the first time, there is not a cookie cutter answer to that. It really comes down to each company's maturity level, the skill sets they have, whether they have cloud architects on staff that really know how to either embed optimization in as they go or apply it afterwards or do small modernization tips, right? I think right sizing is a really good example of that because so many times people say, oh, you have to go serverless to get scale. That's not necessarily true. You can scale EC2. You can size your EC2 instances. You can get some of this elasticity without re-architecture. And that's where right sizing becomes really valuable, because you don't have to go to containers. You don't have to go to serverless to get elasticity.
Yeah.
We can apply these right sizing concepts to an environment that you haven't re-architected in 10 years. We can revisit how to size instances. We can sort of bootstrap the serverless value onto a legacy EC2 based application architecture. Even if it's stateful, even if you don't have like auto scaling capability, we can still size those instances and get you significant value out of it. So we don't always have to re-architect everything just to get cloud value.
Completely agree. So, Rick, you recently had a number of very interesting announcements. So, would you like to share the latest and most exciting thing in your mind that the audience should be looking and exploring right now, because it could be big savings? And what's on the roadmap ahead?
Okay, so I can't share like a huge amount of details about upcoming launches, and they might change and all that sort of stuff. But definitely pay attention to this space, because you're going to see a lot of stuff. So we have a lot of investment, and we've got an incredible engineering team focused on our optimization tooling. So I'd say the rest of this year, pay very close attention to this space. I'll tell you that.
Yeah.
As far as launches that have recently happened, so earlier this week, we launched a new recommendation, a completely brand new from the ground up recommendation for SQL licenses. Now, if you have Microsoft SQL in your environment, you know the license costs are very high. The license cost can be many times higher than the price of the instance itself. And so we created a new recommendation type. And what it does is, if you go enable CloudWatch App Insights, it will be able to look at your SQL licenses and then look at what features are being used inside SQL. And if you're not using the enterprise feature, it will provide you a recommendation to downsize or go to a cheaper license type. Now, that can provide up to, I believe, a 72% reduction on the cost of the instance if you're using.
That is huge.
Yeah, it's really big. License costs are big, right? And so license optimization is kind of a difficult thing. There's some third-party products that do license optimization as well. So providing this as a free recommendation type, you just go enable CloudWatch App Insights, and boom, you get these recommendations. And we even put in the Compute Optimizer product, when you go to an instance that we have detected, we use some really cool AI ML technology to go detect and understand if we think this is a SQL server. And then we provide you a quick little link in a box that says, click here to go enable App Insights really quickly. And then boom, once that's installed, it'll go take a look at the license and if you can downsize. So this will save a pretty hefty amount of money on your license costs by switching to cheaper licenses. So that was one of the launches we did. We did that this week. A couple months ago, we added tag filtering capability within the Compute Optimizer APIs and console in the UI.
Right.
That's huge, because most customers, most people that are using Compute Optimizer need to look at recommendations by their team or org.
Correct.
Yeah, so you need to look at, hey, like, I don't need to look at these 3,000 recommendations. I need to look at the 30 related to my service or my app. And so filtering it down based on your tag criteria will allow you to scope down the product into the area you care about. So that was a really big launch that, UX improvement that we were excited about, that helps customers really get more value by being more precise with the scope of the recommendations. We launched a bunch of support for new instance families a few months ago. We'll continue supporting new instance families as they come out as well. And we've had, I think, like 6 or 7 launches this year alone on Compute Optimizer. So our pace has been really good, and we're continuing to iterate and really put a lot of effort here. We also had a launch on savings plans. Actually, we didn't even talk about this, but we launched the savings plan visualization charts about a month ago.
Correct.
And I love this launch, because so many times customers ask, now, do your recommendations account for my weekend dips when I turn things off, or do they account for my usage patterns? And the answer has always been yes, but no longer do I have to say, trust me, it does. Now I can show the graph that shows your on-demand usage over time, and then the recommended purchase amount, which is sort of just like drawn like a line across your usage. So now you can see the recommendation accounts for your behavior. And then what's also really cool is that graph shows kind of a story of your behavior. So you can see your on demand going up and down every day or every week because the graph shows hourly granularity. And that's a really important trick because a savings plan is an hourly commitment. And so that graph, I love that graph because our engineering team spent countless revisions. We went through so many different versions of that graph and tested it with some of our best customers that really focus on SPs and our own TAMs and account leaders and everything that work and think about savings plans every day to really get a graph that we like and we think we hear from our customers that they really like as well. So that was a launch that we're really excited about. We're getting a lot of great feedback about it.
I really like what you said about using the visuals to convey this sense of, I guess, trust and detail orientedness, where you can see that it's taking into account all of these cyclical behaviors.
Awesome. One last question from me, Rick. If there was one thing you could ask each AWS customer to go and do with Computer Optimizer, what is that one thing that they could do? If they could only do one thing, what is that one thing?
Oh, I would turn on memory.
Okay.
Just because the savings, on average goes up by over 300%. So like if you're struggling to get your company or engineers to take right sizing seriously, if you imagine that amount of savings number that you've shown people or want to show people, imagine it just instantly tripling or quadrupling. That conversation gets so much easier for you when it's such a big. So go turn on memory, and you can do it via CloudWatch. If you have an APM product, we support most of them. That's a free feature. There's like no cost associated with this whatsoever. If you're using CloudWatch, as a tiny little cost to store the data, but it's really infinitesimal. And the amount of savings is it's mind blowing. Again, like we talked about, it's like strapping solid rocket boosters to your optimization initiative.
Well, go turn on memory. If you're watching this and you haven't done it, do that.
Absolutely. And for those who don't know how to do that, again, you can use any of the APM products that are in the market, but there's also a CloudWatch agent for memory that you can install on all of your instances. Pretty much every platform is supported. I think it comes baked in on Amazon Linux too, and you have to turn it on. But the agent basically runs on all platforms everywhere. You can download the agent for free and make sure that it's set up. You could write a simple script that could use SSM agents. If you have SSM turned on, you can use the SSM agent to, install these the memory agent as well and start pushing data into CloudWatch. So make sure that you try out at least one of these many different ways of turning on the memory metrics for your instances, because the benefit of doing that is going to be
We have
huge.
a blog post about that too. I'll post the link in the show notes to that. We have a blog post about how to get this on, because a lot of the Cloud Finder fixers, we want to make sure that data is there so we can use Compute Optimizer.
Correct.
Awesome.
Exactly. Once again, Rick, thank you so much for coming and giving us all this information, sharing this with the audience. I think everyone will benefit a ton from this. This has been an incredibly valuable session. Learning about the magnitude of the underutilization or inefficient utilization of resources I think is big, and I'm hoping that it will drive more customers to get efficient a lot quicker. So thank you so much for coming on the show.
That's my hope too. We have a lot of room and opportunity here, and we're still very early on in the maturity of the optimization industry, right? And it's important for healthy cloud usage. So I'm excited.
And I like that idea of having that layer of taking this automated suggestion and baking that in right into your design, that you're not just going to pick an instance type and then stick with it for a couple of years, right? You're going to have this layer, which is a hugely data-driven suggestion right in there.
Yeah,
absolutely. I would say, let's have another conversation in about 2 months from now. I'll see you both, I'm sure. Let's get that scheduled now, because we're going to have a lot more cool things to talk about.
100%. You can count on it. So we're going to have you back on the show, Rick. You will tell us when, and we will have you back on the show to talk about all the new cool stuff that you guys are working. Once again, thank you for all the work that you guys are putting in. I think it's something that every AWS customer should be looking to leverage, get more efficient. And there's so much to do. All the stuff that people are wanting to do with Gen AI and all these new tools. In fact, just to put it out there, I haven't come across a single organization in the last 2 months that I've spoken to that hasn't got AI, Gen AI related stuff. A lot of them don't know what they're going to do with it, but there isn't a single organization that I've spoken to where there isn't a board level down, mandate to go figure out how to leverage Gen AI to do something interesting and innovative. So the only way you can do that, and those experiments are expensive, the only way to do that is to get efficient with what you're running right now, use those savings and invest them in all these experiments that you really need to go and perform.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry because CloudFix is AWS recommended and easy to use. It's the only tool that fixes cost-saving opportunities and not just finds. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part of all, it works non-stop. Stop overspending on AWS and click on the button to start saving now.